So, nice to see you again. So, things haven't changed since yesterday. I'm still Vincent, I'm still French, and as the title suggests, we're going to talk about property wrappers. But first, we're going to do something a little bit crazy for iOS conference. We're going to take a look at some Android code. So, this is some Kotlin code, and it's actually a good code. So this is how you could implement a network call in Kotlin. So it uses a library called retrofit, and what you can see is like this nice little annotation with this @ sign. And they say, okay, so my call, it's a form that's URL encoded. It says, oh, this is the path of the endpoint that I want to hit. It also says things like, oh, this is the header that must be encoded with the key authorized. The argument is a field that must be encoded as a header. And then this other argument, it's a field of the form, and there is also the key, etc., etc. And actually, in Kotlin, this is the entire code you need to write for a network call. There is no actual implementation. This is just an interface, what we would call a protocol in Swift. And with the annotation, the compiler is able to completely synthesize the actual code that performs the network call. So that's pretty cool, because this annotation, basically, they let Kotlin developers decorate their code, and this annotation, they carry like a meaning that's going to enrich the behavior of the code. And basically, we could say that they are going to let the developers extend their code in a very declarative way. And we do like declarative programming. Unfortunately, for us Swift developers, there are no annotations. Or at least, there were no annotations. Because in WWDC 2019, so last year, something happened. Apple introduced a small new framework called Swift UI. You might have heard about it. And if you remember, in the first code snippet they shown, there was this thing, @state. And you might have been wondering, what is this? Well, this is one of the new editions of Swift 5.1, and this is what is called property wrappers. So here's the same snippet, but like you can see it much better. And you can see that there is a variable. It's called name. It's a string, but it's decorated with an @state wrapper that's going to say, OK, this is a state, and when the value changes, you need to reload, to re-render the view. So yeah, as I was saying, it's a property wrapper. It decorates a property with a custom behavior. And of course, this sounds very similar to the annotation that they have in Java and Kotlin. So what I want to show you is how you can implement your own property wrappers and the different use cases that you can solve, the problem you can solve with property wrappers. And to begin, the best place to understand how a property wrapper is supposed to work is to actually take a look at the Swift evolution proposal where they've been pitched. So if we take a look at it, the clicker doesn't work. Old-fashioned way it is. So we're just going to read the introduction, and we're going to see that it's already going to give us like, oh, it buffered some comments. OK, the introduction of the proposal. And it gives us some nice insight. So I'm just going to read from it. So it states that there are property implementation patterns that come up repeatedly in our code. And rather than having some fixed set of hard-coded patterns, like the keyword lazy or the attribute nscopying, which are hard-coded in the compiler, it would be actually nice to have a general property wrapper mechanism that would allow us to implement this pattern as libraries that we can define ourselves and reuse throughout our code bases. So let's actually implement some property wrappers. And to do this, we are going to use some examples that come from an article of the famous website NSHipster. So the first one we're going to look at is clamping numerical value. So what do I mean by this? Sorry, the clicker is a bad idea. Oh, it works. OK, so let's imagine that we are writing an app that where we are like manipulating chemical solution. So a chemical solution, it has a property that is called its pH. It's a value that says how acid the solution is. And actually, it has a special property, which is that the value must be between 0 and 14. It doesn't make sense for the value to be outside this range. And what we want to implement is a wrapper called clamping, which is going to take as argument a range, and is going to force the value that we set at runtime to always stay inside this range. So how does it work under the hood? We begin by implementing a plain old struct. It's called clamping. And inside, it stores two things in its states. The first thing is a mutable property called value. So this is the value we are going to store in the wrapper. And the other one is the range that we are going to use in order to clamp the value. Pretty straightforward up to now. Then we implement an init. Inside the init, so what we are going to do is that we are going to take two arguments, the value that we want to wrap and the range. We are going to run a precondition to make sure that the initial value is indeed inside the range. If it isn't, it's probably a developer error, so we want to crash. And then we're just going to perform a member-wise initialization. So nothing fancy here. And then to turn this struct into an actual property wrapper, we just need to add one thing at the top, is this new attribute from Swift 5.1, so add property wrapper. And just by doing this, the compiler will now see clamping as a property wrapper. So it will tell us, warning, you need to implement a property called wrapped value. So okay, let's do it. So yeah, the getter, pretty straightforward. We just return the value. And inside the setter, this is where we are going to run the custom logic that we want to have inside our clamping wrapper, which is that we take the new value and we make sure that it cannot go below the lower bound of the range or above the upper range of the upper bound of the range. That's it. With this, we've implemented a property wrapper, our first property wrapper, and now we can use it in our code. So for instance, we are going to write this code, it's going to compile, it's going to work. Then we are going to instantiate a first solution, okay. Then we are going to set its pH to -1, so the value is going to go through the setter of the wrapper. And when we try to read from the value, well, our logic will have been applied, and we will get the value 0, because as we coded it, the value cannot go below 0. If we set it to a value below 0, it goes back automatically to 0. So it sounds like a little bit like magic, but actually it's just compiler magic. Is the sound okay? Because, okay, perfect. It sounded weird on my side. So basically what you need to understand is that basically when you use a property wrapper, whenever in your code you're going to write solution.ph, actually the compiler is going to replace it by solution.ph.wrappedValue. And this is what is going to make property wrapper so seamless to use. It's just like accessing a computed variable, but the compiler is going to make the actual call for us. And the cool consequence of it is that since this is all happening at compile time, property wrappers, they have no minimum OS requirement. As long as your compiler support them, you can use them on any version on iOS, which is pretty cool, because it means you can use them in your code right now. And the initializer also gets some compiler magic. So remember, the init, it had two arguments, a wrap value and a range. And actually, when we instantiated the wrapper, we only provided the range. And it's because by convention, the argument of the init of a property wrapper that is called wrap value, the compiler will set it to the initial value of the property. And this makes it like for a more natural syntax where you can do like a regular assignation doing equal and then the value. And actually, there might be instances where you need to access like the wrapper itself and not just the wrap value. And you can also do it by implementing another property in your wrapper. This time it will be called projected value. Inside we are just returning self. And then if you want to access the wrapper itself, so the projected value, you just need to prefix the name of the variable with the $sign. So if you do some Swift UI, you might have already seen this notation. So we are able to implement a first wrapper on numerical value. And if we were writing an app that is like focuses heavily on numerical computation, well, we could, of course, see many other use cases. For instance, there would be a wrapper called normalize that would help us a lot. Things like rounded, truncated, quantized, etc. But actually, we can, of course, apply this mechanism to other use cases. Something that can be useful is called data versioning. So now we're going to see like how to implement some kind of business requirement for property wrapper. So we are going to implement a wrapper that is going to manage an history of all the values that have been assigned to a given variable. So it can be pretty useful, especially if you do like server side, because then if you need to debug, you have like a log of everything that happened to your variable, and it's pretty useful. So to implement it, we're going to go step by step. So like before, it's just a simple struct. It's generic over a value, and it's declared as a property wrapper. Inside, we store in the state two things. We store the actual value, and we store the history. And it's stored as an array of tuples. In the tuples, you have a date, which is a timestamp, and the value. So this is your history. Then you implement the wrap value. So the getter, pretty simple. You just return the value. And in the setter, when someone sets a new value, what you do is that you assign it, and then in the history, you append a new tuple where there is the current date and the new value. And you provide an init in order to make it work nicely. And then in your code, for instance, let's say that we are working on an application that manages like expense reports. These reports, they have states, so they can be like submitted, received, approved, or denied. Well, we can, in our code, in our like model, we have a variable which models the state, and we just need to add the at version. And now this variable will be tracking an history of everything that happened. And if at some point we run into a bug, we are going to be able to expect this value, either with like a debugger or with accessing logs or things like that. So for the moment, we've been using property wrappers, but we've used them as kind of a standalone feature, meaning that everything was stored inside the wrapper. We were storing data and adding a layer of business logic around it. But actually, we can go also further, and we can try to like make property wrappers interact with other APIs. And a very good example for it is user defaults, because user defaults, they are used everywhere in iOS apps. So this example, it actually comes from Antoine van der Lee, and he came up with it during WWDC. So it shows that it's something that comes up like very naturally. So in our app, when you use user default, if we want to have some kind of like type safety, because we don't really like stringly typed APIs in Swift, we might be finding ourselves writing something like this. So we write an extension on user default. We're going to have for every value that we store an enum, where we store the keys that we use to store and retrieve the value in the store. And then for every value, we're going to have a computed variable with a setter and a getter that are going to call the API from user default. The downside is that every time we add a new value in the user default, we need to write a new computed variable, and we need to write again the setter and the getter. On the other hand, when we actually use this code, the ergonomics at the call site, they are awesome. So very clean call site, but boilerplate. And actually, when you have this situation, it's a sign that a property wrapper can really help you, because this is what they're good at, maintaining clean call site while reducing boilerplate. So it's a perfect use case for a property wrapper, so let's implement it. So like before, it's a simple struct. We call it user default. It's generic over a type T. And this time, inside the state, we are not storing the value, but we are storing the means to access the value. So there is the key that we use to access the value, store it, and retrieve it in the store. And there is a default value. Then there is an init. It's just member-wise initialization. And then everything happens in the wrap value. So in the getter, we call the user default API with the key. We try to cast it. If either the cast fails or there is no value, we return the default value. And in the setter, we set the value in the user default store using the key. And that's it. Now we can use it. So now we would have in our app a struct called user default config. And you can see that we would write this in a very declarative way, because we just say, OK, so I have this static variable. It's called as_seen_app_introduction. And we use the wrapper to say, OK, this is the key we use in the store. This is the default value. And that's it. We don't need to write the setter and the getter every time. If we want to add a new variable, we just add it. We add the key, the default value. That's it. No more boilerplate. And of course, it's going to work as expected, meaning that the store is going to get indeed setted, and you can retrieve the new value after you set it. So here I focused on like smoothing out the interaction between our code and user defaults, but it's an approach that basically you could apply it to any data store. So up until now, we've seen one thing. We've seen that property wrappers, they work on properties. So when I say this, you might be thinking, OK, thank you, Captain Obvious. It's in the name. But what I mean by this is like, wouldn't it be cool if we could also have like function wrappers, to have property wrappers work with function? So Swift doesn't provide function wrappers per se, but Swift also loves functional programming. And it means like three things. Usually when we say Swift is a functional programming language, we say functions are first-class citizens. It means three things. It means like a variable can store a function can take a function as an argument, and also one we tend to forget, but a function can return a function. And when we put all of this together, if we think about it, we can see that, well, we can store a function inside a property. So basically, property wrappers, they can work with function. OK, so now we are able to decorate code with code. So what can we do with this? We're going to keep it simple use case. We're going to implement a cache for a pure function. So just a reminder, a pure function, it's a function, you give it an argument, it always returns the same value, and it performs no side effect. Think mathematical function, they are pure function. So if you want to implement it, there's a lot of things. I'm not sure everyone sees it, so we're going to go really step by step. So first, the struct. We call it cached. It's a property wrapper. It's generic over two types, input and output. And we add the constraint that the input must be hashable because this is something that our cache is going to require. Then inside the wrapper, we are going to store a function, and it will be a function to which we will add a caching logic. Okay, and this function goes from input to output, so no surprises there. Then we are going to write an init. Pretty simple, we just say my function is going to be escaping because of course we are going to store it. And you can see that we are calling a function called add caching logic 2. I'm going to go into this function later, but this is where we are actually going to implement the caching logic. Then let's move on to the wrap value. So the wrap value, pretty simple also. In the getter, I just return my function with the caching added to it. And in the setter, just like in the init, I take the new function, I add the caching logic to it, and I store it in the state of the wrapper. So as you can understand, everything is going to happen inside this function. So let's take a look at it. So it's called adding caching logic 2 function, and it takes an argument, a function from input to output, and it returns a function from input to output. Okay. Inside this function, we are declaring a local variable. It's a cache. It's a dictionary with input as a key and output as the value. And we init it with an empty dictionary. Then we said we need to return a function from input to output. So OK, let's return a function from input to output. And inside the function, things are going to be actually pretty straightforward because when someone calls the function, what we're going to do is that someone calls the function with an input. We say, OK, we look in the cache. Is there a value for the input? If there is, we just return it. And we don't perform the computation, of course. If there isn't, we perform the computation, we get the output, we store it in the cache, and we return the output. So as you can see, it's pretty simple. Something you might be wondering is, why is the cache declared here and not as part of a state of the wrapper? The thing is, if you try to do it as a part of the state of the wrapper, which is like the intuitive way to do it, you will run into an issue because your function, you are returning a function that would need to capture self in order to mutate the cache, and Swift doesn't allow it. So what's happening here is that actually cache is a local variable of the static function, but it's also captured by the function you're returning. So basically cache, it acts as we could say like a private variable of the function you are returning. It's a technique that's called scoping a variable inside the function, and it's kind of the functional programming equivalent of a private variable. And it makes the compiler very happy. So there were a lot of things, but now when we actually want to use it, it's going to be pretty easy. Let's say like we have an app that does a lot of trigonometry, and we want to cache our result in order like to improve the performance. So, okay, so we want to have a cache version of the cosine function. So we say, I want to have this static variable, which is called cache cos. It's just a function that calls the cos function. And since we added the @cached, the function we've just setted is going to be wrapped inside this caching logic. And as you can see, from the call side, from the user point of view, you don't really need to do many things. You just say @cached, very declarative, and that's it. You've added your caching mechanism. And if you run the code, you will see that, OK, first time I call my function, it takes some time. Here it's like 48 microseconds. But now the value, the result for the value has been stored in the cache. And if I call it again, well, of course, as you can expect, it's going to be much faster. Here you've won like 2 orders of magnitude, which is pretty nice. Of course, it's a very like naive way of implementing a cache, but we could also add another argument to the wrapper, which would be like maybe a caching strategy, and you could do something more involved with things like least recently used and more involved caching strategies, like depending on your use cases. So this cache wrapper is a good example because it shows you like how you can decorate a piece of code with some custom behavior through a property wrapper, but it's still pretty simple. But in our code, we can actually find examples that we could rely on a lot. For instance, in our apps, it's sometimes useful to have functions that are going to deal with timing, things like delayed or debounced. If you use Eric Swift, for instance, you might be familiar with things like debounced. Well, it's actually pretty easy to implement a delayed or debounced property wrapper. If you go on GitHub, you will find many implementations. And it can be actually pretty useful inside your code because you can have like a handler, just decorate it with delayed, and that's it. You've added a mechanism to your code. It's kind of acting like some sort of, you could say like pseudo keywords, and I think it's like pretty cool. You could also implement things like thread safety by adding a wrapper called thread safe that would basically like wrap the execution of a piece of code around a lock or any other like synchronization mechanism. And you would be able this way like to add thread safety also in a very declarative manner, etc., etc. There are many possibilities, and basically it's all going to depend on your code base. And when you go back to your project with now the knowledge of how property wrappers work and how they can be implemented, I'm sure you're going to find like lots of new examples. But I want to show you a last one. So this one, it's more of a proof of concept, meaning that I don't recommend you use it in your app in production, but it's very useful because it shows like just how far you can go with property wrappers. So remember the Android code? So this is how they were implementing the network calls. For instance, they were implementing a post call this way. So it would be pretty nice to use property wrappers to also have a completely declarative networking library. Unfortunately, for now, there is a limit. You cannot compose property wrappers, so you cannot have like 2 property wrappers on the same variable. It's not possible yet. So we cannot implement a post, but we can still implement a get. And we're going to try to implement a way to declaratively write a get call and have the compiler synthesize everything for us. So it looks like this, and we're going to go step by step. First thing is we're going to define a type alias. Why? Because when we do network calls, we have completion handlers, and they make like signature functions crazy, and this type alias is going to help us like make things much more legible. So it's called service, it's generic overall response, and it's a function that takes a completion handler that is going to receive a result, which is either the response or the error. So it's what you expect for any network call in Swift. It's very close to what you have, like for instance, with URL session. Now we implement the property wrapper. So it's a struct, we call it get. We say it's a property wrapper. Inside this state, we're going to keep things simple. We are only going to store the URL. In the init, we take the URL as a string, because this is probably how the developer is going to write it in his code. And then we turn it into a URL. And since we want to keep the code short, we're going to do like force and wrap, and we're going to crash if the string is not a valid URL. Remember, this is more a proof of concept than a production-ready code. Then we are actually going to implement the wrap value. So our wrap value, it will expose a service that returns a string. So it's only going to be a getter, because it wouldn't make sense like to set a new service. And inside the getter, so we said we return a service. OK, so the service is a function, so we return a function. The function takes a completion handler. OK. Then inside the state, we only have a URL. So let's use it. Let's use URL session in order to create a data task that is going to retrieve data from the URL, so perform the HTTP call. So as you know, data task, it takes a closure in order to return its result. And this closure has 3 arguments: data, response, and error. So first we say, if there is an error, well, call the completion handler with a failure, and you propagate the error, and that's it, we're done. Otherwise, if there was indeed a response, we're going to take the data, parse it as a string. We assume the data is there. We assume it's UTF-8, and we force and wrap everything, once again, keeping things short. In real code, of course, we would return an error if there is a mistake. And then we return the result as a success to the completion handler. And of course, we don't forget to actually start the task. And with this, we've actually implemented a way to have get HTTP call implemented completely through a wrapper in a declarative way, because now we could write this code. So in this code, I'm going to try to hit on the sample API of OpenWeatherMap. So I'm saying, OK, I have this struct. It's my API. I have this static var. It's a service to get the current weather. And I just need to give the property wrapper the URL. And that's it. With this, I have implemented my network call. Then I can, like in my code, say, OK, well, API get current weather, call the function, and do something with the result, for instance, printing it. And if you run this code, you will see that, yeah, in the console, you indeed like get the JSON result. So we are able to implement a getter in this very declarative way. Remember, it's more a proof of concept. I wouldn't recommend you use this in your app because you cannot like implement everything like post, etc. But it shows like where property headers could be headed if there were some more additions like the ability to compose them, principally. So, time for the obligatory recap slide. What should you remember from this talk? First thing, property wrappers. Basically, the thing to know is that they let us wrap properties with custom behavior. They are extremely good at removing boilerplate. Actually, as we saw in the pitch, in the initial pitch, that's why they were made for, to remove boilerplate when there is a pattern in the way that we implement properties. They also provide great ergonomics for ubiquitous constructs. So the idea is that if there is a pattern that comes every place in your app, it's going to be very nice because you are going to be able to encapsulate it and to have the feature without really like worrying about it when you use it. You will decorate a property with a wrapper, and then when you use the property, your business logic is going to run, and it's going to be all very seamless for you. And this way, your code will get more readable, and you will be able like to focus on what the code does and not the little part of business logic that were like always in the way. We also learned that they can be applied on functions, even though there are some limitations. The main one is going to be like when you try to manipulate self, you're going to see that there are some limitations, but you can still do some pretty cool stuff. Now, if you abuse them like everything, they can hurt code readability, meaning that if you start like introducing property wrappers for everything, it will hurt the readability of your code. Why? Because when a variable is used, if it is decorated with a wrapper, a custom logic is run. But the thing is, like, if you read the code, you might not know that there is a wrapper on this variable. You need like to look to do like some kind of alt click to see, okay, what is the declaration of the variable? So you should be like, use them only when it makes sense. Don't try to use them everywhere. You should use them only when there is a consistent way to use them everywhere in your app for a specific purpose. And finally, we can, of course, be thinking that they will lead to new and exciting frameworks. Actually, there are some. Combine and SwiftUI, they rely heavily on property wrappers. And we can maybe hope that Apple in the next years, they bring some more features, and we can get some pretty cool stuff like everything they have on Android, where they have the annotation. It allows them to, I've shown you to synthesize network calls, but they are also able to perform compile time safe dependency injection through property wrappers. And it would, of course, be pretty awesome if we had the same thing in Swift. So, thank you all for your attention. If you want to get the slide, I will post them on Twitter. So this is the link to my account. And actually, in the slide, you will see that there will be a little bit more content than what I've shown you, because I had to cut some content because people told me that you are up for some more memes before we leave. So, 3 more, only 3. But they're very good. So, iOS. There are things that annoy us on iOS, but as with any language, there are what you could call like the usual suspects. And it's, of course, UI WebView, code signing, and the app review team. And speaking of things that annoy us or make us feel like a little bit uncomfortable, how do you feel when Apple says that core data is the easiest way to store data in an iOS app? And to finish, so we are at an iOS conference. We've seen talks about SwiftUI, about Combine. We like the content that we've seen because it was great content. We want to use it. Unfortunately, when we get back to our companies, to our code bases, it's not going to happen. You need to support iOS 9, or 10, or 11, or even 12. It's not gonna work. Thank you.
Awesome.
Do we have time for question? Yeah, we do.
We have time for 2 questions.
Yeah. Okay, so first question is a good one. It says, the property wrappers, sometimes we could use a function instead of a wrapper. So how do we differentiate the usage of the two? That's a very good question. Basically, it's a matter of consistency. Apple has made like a statement with property wrapper saying, okay, this is the preferred way to add features to a property. So yeah, when it makes sense to use a property wrapper, you should, because your code is going to look like any other code. It will make your code base more maintainable. But actually, yeah, there are times where a function could be used. I'm not sure it's going to be clear to everyone how you could use a function. I have a talk about like how you can do this with functions. So I will also like tweet the link. So maybe the question will be much clearer, and it's a subtle difference, so it will be more easier if I open it on Twitter. And the user default wrapper you showed has no way of removing a value from the user defaults. How can that be implemented? Like thinking about it, like right now, I would say if you set the value to nil, it could remove it. But if it's like some base type like int, you won't be able to do it. A way to do it would be like to implement the projected value, to have on the wrapper a method called remove, and then if you want to remove, you would do like $ name of the variable to get the wrapper, and then remove. It's actually a very good example where the projected value and accessing the wrapper itself is useful for like extra features. Okay, and the rest of the question I'll answer it on the Slack.
Okay, thank you.
Thank you.
Vincent.